Hi, Lake Speed Jr., Total Seal Piston Rings, here with my buddy Charles Navarro, and we're here in Moments, Illinois at LN Engineering to talk a little bit about engine break-in, engine assembly, because Charles, you can have the best parts and pieces, everything planned out, mapped out, best of the best. It can still go really bad. You know, contamination, we've talked about in a previous video. Fuel dilution is a major source of oil contamination. Hey, that's the main reason why motor oil gets changed more often than gear oil and transmission fluid, is because of contamination from combustion, blow-by, fuel dilution, all those things. But there's another source of contamination that can kill your engine right from the beginning.
Yep, one of the biggest mistakes that we see is improper preparation, especially cleanliness. Especially in our application, everything we do is Nikasil, that when the cylinders are honed, you have Nikasil dust mixed with honing oil. And if you don't clean the bores properly, you fire that up, the rings and pistons are instantly worn out. So what we advise is using denatured alcohol along with lint-free wipes. We have here some wipe balls, but also Kim wipes. We use those a lot in our engine assembly. You don't want to use red shop rags, paper towels. You have to use
brake cleaner.
And brake cleaner is another one. We see people use brake cleaner or carburetor cleaner. And it's 20 years ago, that stuff,
it was chemically different.
it was chemically different. Now, if it's you can buy it in the state of California, it's not going to work to clean your engine. So denatured alcohol, you can get it at your local hardware store. You can buy it at the drugstore, although it has pink color in it, but it won't hurt anything.
Right.
But that's really the best product to clean all your engine parts. That's what we exclusively recommend, and you keep wiping until the Kim wipe or the wipe ball comes out the same color that it went in. And especially it's good with the Kim wipes because they're white. And if you see any dirt whatsoever, I'd probably use the wipe balls for the first pass, and then use the Kim wipes for the second pass or third pass or fourth pass.
Right. Well, it's key because, as you're mentioning, the honing oil has all these little bits in it. A lot of brand new parts look really nice, but they'll have some kind of rust preventative on it. And a lot of times those things will hold microscopic particles you can't see with your eye, and brake cleaner only will move oil. It doesn't dissolve it. You've got to have something that has the cutting power, that's a true solvent that can really get in there and remove it from the surface so that surface can be completely cleaned. And there's a couple reasons for that. Not only does it need to be cleaned so that it doesn't have contamination, number two, you want it to be clean so the oils, the lubricants can do their job to create the tribofilm on there, the ZDP, the moly, all those things, they're going to be doing their job. They can't do it as effectively and as quickly if it has to displace a lubricant that's already in place that's usually going to be pretty surface active to be able to be a rust preventative. So getting it clean, really, really important. Then you need to go ahead and begin to apply the proper lubricants on it. And, it's been around for forever, but it works pretty dadgum good, especially on Nikasil cylinders. So talk a little bit, Charles, about what you guys recommend in terms of how to properly lubricate during assembly an engine.
Yeah, the biggest thing that we want to make sure that you don't use, we're not a big fan of really thick assembly lubes, especially in bearing areas, in your rings. You want to use something that's thinner, that's not going to give you a false feel, so that when you're turning the parts, rotating the engine over, you can feel things. That using really thick assembly lubricants can mask if you have a problem somewhere. And obviously there's some places on camshafts, lifters, you need
something high pressure.
You need something high pressure for break-in, but in most cases using engine oil is actually, break-in oil is probably a good lubricant, as long as you're not going to be putting this engine, put it together and sitting on a shelf for years. Then in that case you probably want to use something that has a little bit more tackiness to it so it stays put. because you don't want all the oil to run off, and then you have a situation where you don't have adequate lubrication for that first startup, because not always can you prime an oil system
True.
in an engine. Sometimes the only way you can prime it is by turning it over. And a good example with the Porsche M96 engine, that you can crank it on the starter all day long, it'll never build pressure. Not until it actually fires up will it actually build pressure. So we see customers try to crank one of these engines over, spark plugs out to build pressure, and will actually wipe out all the bearings in the engine, because the pump can't pump oil or prime that system itself. So either you have to pre-prime the system using a pre-oiler,
Yep.
or you have to start-stop the engine so the engine goes at enough RPM to actually prime the oil system. But
Right oil, right place, right time,
Yep.
right amount. Every time.
But basically, all our piston cylinder sets, whether it's a water-cooled block or an air-cooled block or air-cooled cylinders, we provide detailed instructions, what lubricants to use, where to use them, all the proper prep procedures. But that alone, like I said, using the right lubricants, the right parts, following all the directives, you can still mess it up when it comes point time to breaking it in.
Oh, of course. As a piston ring guy, I have to say one thing. Proper piston and ring lubrication for assembly is not taking the piston ring assembly and dumping it in a coffee can full of ATF, by the way.
Yeah.
We just don't want to do that. Just want to put that out there, a disclaimer that don't really like that idea. You know, it's that Goldilocks and the Three Bears. Not too much, not too little, just right. You need a little bit of oil on the skirts, a little bit of oil on the rings, but you don't want to put it in the coffee can and dip it in there. It does happen. You would be surprised. So that's why it's a public service announcement to say, don't do that.
Yeah, and don't use synthetic either. That's the
Right.
other.
Great point.
We run into that with these modern cars, and there's a sticker on the car to use this particular synthetic oil. So they rebuild their engine, and they're just following what the sticker says on the car and fill it in. Nothing's ever going to seat. Synthetic, the rings are never going to break in. And at that point, you got to pull the whole engine back apart, clean everything, deglaze the bores, put new rings in it, and start all over again. So it's really important, even if you're not building a Porsche engine and you're not, it could be any application. You just want to make sure whatever parts you're using follow whatever directives are provided with those parts. Read the instructions. There's valuable stuff in there. I know I'm guilty of it, that I just want to dive into it.
Just get to it.
And get to it. I don't have time to read instructions, but there's lots of valuable information that we've ascertained. And usually when we put something in there, it's because we've learned through experience that, or someone has messed something up, and then we try to put that into the instructions so that no one else has that same problem in the future. So.
Oh, exactly. And for those who are saying, well, why is this idea of breaking oil and seems complex? Well, the reality is, in the old days, you had different bore materials, different roughness, different coatings on the rings, and what you could get away with back then with those materials was what you could get away with back then. With the oils at the time, all that package, that soup, you've heard me talk about before, ring seal soup, that combination allowed it to work following those guidelines. Well, today's materials are different. Today's oils are different. The ring materials and coatings are different. So you need a different recipe. And then from the factory, sometimes things are different. That they may have different materials or coatings and processes and things going on. So what we're telling you now is this is a proven recipe of using the right lubricants, the right process. And that brings up a good point. That process is just as important as the products. One thing we hear all the time, oh, I fired the engine up and I let it idle for a little while, and I would take it out for real short drives and turn it off. Didn't want to rev it up too high or get the engine too hot. Charles, tell them a little bit about why that may not be such a great idea after all.
Yeah, because the way additives in oil work, you need heat, you need pressure, load. That's what activates all the additives for the oil to do what it needs to do. And likewise, you need stuff to wear in. That all that does the cylinder pressure, the speed. You want to run an engine, and Lake will cover this a little bit further. But one of the another big issue we see is when people don't break in the engines properly, i.e. being really gentle with it, that the engine just doesn't perform as well. It'll burn more oil. It might smoke. It just isn't all that it could be. And people say, well, don't rev the engine to redline. Well, if you built something wrong, if you assembled it wrong or something's wrong, if you take it to redline, you're going to find out.
Yeah.
It's better you might find out right away than you just sit around putting around and not revving the engine, and then you prolong the inevitable.
Well, the other thing, too, is there's a big difference between redline and idle.
Yes.
Goldilocks and Three Bears again. Not too much, not too little, just right. You can get out there and drive the car. You can give it full throttle accelerations. You can go within, say, 1,000 RPM of redline, which will be enough RPM to generate the friction, the heat that all the additives need to bring everything up in the engine, the temperature, so that the metal is actually, heat cycling, which is a good thing for all the components in the engine. And then, most importantly, without that cylinder pressure, without load, that hard acceleration, what doesn't happen is you don't get enough pressure above the piston. Without pressure above the piston, what happens is the rings use that pressure. Ring tension that you measure with your hands, that's not what seals the piston ring to the cylinder wall. It's the gas pressure that gets into the ring grooves and forces the ring out against the cylinder wall. That's what makes the ring seat. Without cylinder pressure, the rings will not seat, regardless of what you did down here. So it's really important. Obviously, you don't want to go out there and go 500 RPM from redline with the engine dead cold. That makes no sense. You bring the engine up to operating temperature at a very casual rate. Once it's at temperature, then begin making those series of successive RPM, successive load accelerations if you're on the road or a chassis dyno, or if you're on an engine dyno, then you can just make the pulls. Bring up temperature, put that load in the engine. That's what's going to get your piston rings to seat, because it's really, really important, because you need those rings to seat not only for the efficiency of the pump itself, that's all an engine is an air pump, but also to keep that contamination out. We mentioned it earlier about all the debris and things that could be introduced during engine assembly and how that can be damaging the engine. But that fuel dilution, combustion blow-by, because the rings aren't seated properly, all that does is raise the wear metals throughout the whole engine. And speaking on that topic, Charles mentioned it earlier, and it's a really good thing to bring up. During engine break-in, that's the highest amount of wear, like normal wear, your engine's ever see, because all those parts do have to wear in. That's where taking a used oil analysis, take that sample of that break-in oil, have it analyzed, that's your high watermark for wear for your engine. Because what's going to happen is, during that initial sample, should be the highest. Then it should drop as the engine breaks in normally and finds its baseline. So you can see that progression to know, hey, am I good? Are things working in? Yep, they're just fine. You don't have any problems. You have a nice gradual slope dropping off in wear metals, which tells you your engine's good. Then you can also note that, hey, if just say, for example, that you had 17 parts per million copper during break-in. All right, if your engine ever sees anywhere near 17 parts per million copper ever again, you know you have abnormally high wear for your engine. Super important to know that. So these are some little things you can gauge to gain information about your engine to ensure the health and performance of your engine long term. Because, hey, you want to buy the good parts because they will serve you. Better performance, better longevity, but you've got to put together the process behind it. And hopefully this video gave everybody a little bit of insight into what that thought process is in order to maximize the value of your parts. Hope you enjoyed the video. Thanks for watching.
Thanks.